Why does the book say assume the domain is restricted to variables that prevent division by 0, or something to this effect.
Because it's obviously divided by 0, then
Okay, so I know dividing by 0 is a problem, right? That much at least should be clear. But why does it say it in the problems where I'm not really dividing anything, right? Like, you know, the directions are reduce, example, reduce, blah, 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 to lowest terms, yada, yada, right? Assume this business, right? Why do I need that to reduce x squared minus 4? Oh, no, this is going to be the same thing I made in the first class. But why do they say reduce and assume this? Shouldn't I just frickin' reduce this?
Because there's a spot where you can't do it.
So this is about, right? So I say, okay, this thing is this x plus 2 times x minus 2, right? Over x plus 2. But then those things cancel, don't they?
they become ones.
Yeah, they become 1.
Then
So I'm left with x minus 2,
Why is
right?
our math system imperfect like that?
Yeah, so what's the, like, where's this assume? I didn't assume anything in this problem, did I?
We have to assume that x is not 2,
Why?
because then it will equal 0.
Yeah, but I mean, I didn't care what x was. I wasn't even playing a game with x.
It's in your equation, of course you are.
This is where the assume steps happens.
Oh.
Really, because of exactly what you're saying.
It's
You
a
see that?
variable, we don't know
Yeah, it's a variable. I don't know its domain. But over here, 2 is bad, right? Or negative 2, really. Right? X can't be negative 2 over here. Over here, can x be negative 2?
the, yeah.
Yes.
Yeah, sure. Right? You guys see the problem? If I think about these as functions, the problem should become really, really reasonable. If I've got a function, f of x, that looks like x squared minus 4 over x plus 2, really I'm asking, how is f of x different than this other function, which is pretty similar? Right? X minus 2.
So then there's
These aren't actually the same function because the domain on this one, right?
So does that mean that
Yeah.
the function of dividing something is like a number that you add onto it, so that there's numbers that aren't numbers that are there, even though they're
Kind of, yeah. So when I did that canceling, I should have, when I did this, I cancel, and I said, okay, that is this. I should really remark, except when x is negative 2. You guys see that? When x is negative 2, these actually aren't the same thing at all. That one's an undefined quantity. This one's negative 4. You guys see that? So that assume thing is really a question about domain. The domain on this guy is R except for minus 2. The domain on this guy, what's the domain on this one?
R except for 2.
Even 2 has one.
So naturally, this is the domain, or the domain on this side is,
all
yeah, all real numbers. Because I know how to subtract 2 from numbers, right? kind of regardless of what they are. There's no problem with subtract 2. You guys see that's what this function does?
Well,
So-
unless it's infinity.
One way I can think about it is it's a line with slope 1 and intercept -2. That's another option. When I squish that kind of thing, squish that kind of thing onto its domain, I get all the reals. You guys see that? So the reason that we're saying this assume is so that you don't have to say this thing equals this and then write a sentence about which variables are excluded. You guys see that? It's fine for the x's, right? Because you just, every time you cancel the linear term, you get it can't be the thing that makes that term 0. But when you're canceling one of these a plus b minus 2c things, I don't want to have to write down whenever a plus b minus 2c isn't 0, right? You guys kind of see that? So how do these graphically differ? Can I do that?
Line of Bravo.
So this one's a line, definitely. So it's got intercept -2. So there's a point 0, -2 on there. And it's got a slope of 1, right? So if I go over 1, I go up 1. So it's got the point 1, -1 on it.
The other one's the same thing, except it doesn't have that point.
Exactly. The other one is the exact same thing, except it doesn't have which point?
The 0.
No.
It doesn't, it's x basically.
So 0, -2. Where's my problem at?
X can't be -2.
Oh, right,
Okay, so where's x is -2 on this picture?
Y is,
I gotta go left 2, right? Okay, and then I go, yeah. So there's a hole here, where on the other one, right,
There is no.
there isn't a hole. Here there's a point, right? If I go back 2, there's a point, -2, comma, -4. So the difference between these is that canceling, spelled wrong, plug, also spelled wrong, plug, the hole, and capitalized for some reason, right? Because I'm out of time. Cool? So when we think about this canceling process, I want you to think, okay, that's plugging the holes in the function. So if I get to a function I can graph, I can get the graph of the other one by putting those holes back in. You guys see that? Okay, cool.
so we don't think of infinity